All right, thank you all for having me here. I'm Andrew. I'm from Teleport. This is a product studio being incubated by Flashbots X. We make thought-provoking applications enabled by trusted hardware and confidential compute, which I'll give you a few examples. First of all, I am also a board member of the Zcash Foundation. I want to say, did I get the right clicker? I want to advance my slides. Should I try the other? Yeah, there we go. So first of all, I'm going to talk mostly about a non-crypto kind of thing that I want to make the point that we should apply all of our Web3 and cypherpunk values to. But first of all, this is a really important moment for privacy. So I really want to shout out to everyone who has been working so hard on developing the technology and the philosophy and culture behind the use of privacy-enhancing technologies for so long, even before it was adopted as a really important, positive, mainstream thing to do. Yeah, round of applause for everyone who has been working on this tech for a long time. No one can control when a fad happens or a trend happens, but all the hard work leading up to this is what makes it possible to sustain that, right? So everyone's going to look now at, oh, we should be adopting privacy, we should think about it. But then they'll stay for the depth of technical work and culture that's been brought to this. Okay, so with that aside, the point that I really want to make today is that we should be, widening our aperture a bit. We should be looking about how to spread the cypherpunk values, not just to digital assets, where it is very important and we're doing the right thing to that end, but we should be looking at bringing these to other kinds of areas as well. So I'm going to be talking in this talk about social media and algorithmic feeds and how you can bring cypherpunk technologies to this kind of area. And I'm also going to make the point that we should be especially embracing trusted hardware and confidential compute, which compared to the ZK proofs and other cryptography that you're used to are way more of an unsatisfying compromise and not as good as in the trust model sense. But they're really the thing that we should be using now to branch out into beyond digital assets, bringing cypherpunk values to the world. So I'm going to be talking about some application examples that are built on top of TikTok and short-form video. Short-form video is actually a really important area that we should be looking at. It's something that is, dominating the attention spans of youth and adults on YouTube Shorts as well. Usually you hear about short-form video in the pejorative sense, like it's wasting everyone's time with slop and encouraging very low agency, just like I'm addicted and doom scrolling kind of behavior. There's actually a lot of reasons to be interested and optimistic about the potential of short-form video as a platform as well. TikTok has a STEM feed, a STEM button. That's where you have your, nominally educational videos as well. But it's, compared to the For You page, it's not algorithmically tuned. It's kind of boring, but, I think there's potential there. And the creator tools are always near there as well. So short-form video doesn't just have to be about passively receiving content sent to you. It can also be a way that you can be motivated to produce something and share with others around you. So I think this is a really important place to meet, consumers and, not just the techies, but other people where they're at. Now, the basic problem, and why I'll get to adversarial interop as the real important thing that we should be looking at, is that the platforms associated with short-form video that give you the algorithmic recommended feeds are the masters of all of the data and control the interactions that you have. In principle, user-generated content, anyone can record themselves with a selfie stick in a phone. That should be really good for, creativity unleashed and being able to form societies and communities, have things to share with your friends. It's nominally peer-to-peer. There's relationships of interaction between content creators and their audience members and following. Audience members can also be creative creators themselves, so there can be, a back and forth. The reason why this works so well and it's proliferated so well is because the platforms are really well tuned. They know your behavior so well from the behavioral data that they collect that they do a fantastic job of routing content right to you when you're definitely going to watch it if it's the next thing that shows in your feed. They even also give data to creators that guide them towards making slightly better content that is going to be watched by people and more effective. This, of course, is data that the platform has, and so they get to put their fingers on the scale and tip it to make you watch addictive content or something that's going to make you buy more products rather than, actually build some kind of health or learn something or build healthy connections with other people you're sharing videos with. So at the bottom is the design space of information diet apps, meaning apps that will attach to the existing platforms and make use of the data which otherwise would be held by individuals, unable to share them with each other for privacy reasons. This is a design space that we can actually bring cypherpunk values to, and I'll give some examples of this in a second. I will actually just go straight to giving a couple of app examples. These are not live right now. They're like in review in the App Store, and hopefully we can make a launch announcement about these by the end of the week. I will give just 2 examples, though we have a couple others. So the first one is called Feedling. So this is an application that it gives you an interpretive feedback of your behavioral patterns on TikTok. So this is a digital pet that you can keep and adopt the digital pet with a group chat or your friends that is fed the same information diet that you are fed. So every time you watch a video about cats, your cat avatar picks up some skills based on whatever was in the video. And it pops up like while you're watching the video as like a little pop-up, so you get to see this in real time as you're watching it. You can think of this as surfacing insights about your behavioral patterns that you didn't even know that you had, delivered to you in a way that's a little bit, subliminal, not like on an entirely separate app, but right there where you're saying it. Now, for this to work, and I'll get into the technical details of how, this has to be able to observe your watch history and link it into this separate application. Let me give one more example that's even a little more evocative about why this is an interesting kind of technical paradigm. So this one is called Sync. And the idea is that it is an AI agent that it is in a group chat that you join. And this agent gets to see the group chat the discussions in your group chat. It also gets to see the delegated watch history of both of the people in the chat, or all the members of the group. And the idea is that it's going to drop in insights into the group chat when it's relevant or likely to spark a conversation or be productive to do so. So in this example, someone is starting to speak in kind of coded references to a TV show that they're watching. So it's interesting to drop a card revealing, oh, the other person actually was also interested in this TV show a little while ago, so there's some insight there. Some other examples, I won't go through too many of the examples, maybe you kind of get the idea. The other ones that are interesting are where there's some complementarity, like someone has been binge watching educational videos on building something, and someone else in the group chat has just started down this rabbit hole. You should probably recommend, the new learner should be in contact with the person who's just acquired a lot of expertise. There's some value to the insight of matching them together. It's also interesting to roast you for when your watch history betrays the wrongness of what you're saying, like you're talking about health, but actually your watch history reveals that you're staying up very late watching videos long past your bedtime. So you get the idea of the kind of things that this would show there. Just to abstract from, what's the point of what's going on here. So the platform has all of this behavioral data about what you're watching. You individually can go and look at your watch history and see what's going on. There's no facility in the existing platform to share this watch history with other people, and nor would that be a good idea. You wouldn't want to share your entire watch history. That's too personal and would be too much sharing. That said, there's still some value that's like left on the table, which would be insights that would be meaningful if they were brought to the surface, that are only apparent from the application viewpoint of this aggregate data from multiple users. It's not a good idea to share all of the data, but it's a wasted opportunity not to share any of the data. So what we want is the ability to define apps that work like this and be able to get the value of sharing without actually having to give up all of the control over your private data to do so. So this idea of building apps that retake the power of private data that the platforms currently have, with or without their permission, and in particular without waiting for their permission to do so. This is an instance of the problem of adversarial interoperability. That's a phrase coined by Cory Doctorow in an essay while at the EFF. And the gist of it is that if you want to really get a way to get more of the value back to yourselves rather than simply giving control over it to the platforms, you need to have an ecosystem, technology, and a will to do so that isn't waiting for the platforms to do this for us, but is able to do it ourselves. Now, I'm going to talk about trusted hardware and confidential compute. I think that I gave the background on this, that it's a very imperfect technology, and I hope you enjoyed Quintus's and Ahmed's talk about the trustless TE effort. Long term, that kind of effort is the only good solution to be able to do. I don't want to convey that we should settle for being stuck relying on Intel and Azure to bring this to us, but to be pragmatic and to actually expand to some areas beyond just digital assets. This is really the right technology for the moment that we should use. So basically, on clouds right now, there are confidential compute VMs. So these are VMs where you can run encrypted code and process encrypted data, and the cloud promises that they won't look at it. Not only do they promise they won't look at it, they use hardware features in Intel Xeon and AMD. Like half of all the server class processors have support for this confidential VM mode. The thing that's imperfect is that these have a bad track record of bugs. The bugs eventually get patched. There are ways that you can mount physical attacks, so you have to trust that the cloud vendors are not actively exploiting those physical attacks. There's at least a little bit of a separation of concerns, like the hardware manufacturers and the cloud would have to be violating each other's intended agreements and use of their tech to do so. The main feature that these have is isolated execution and remote attestation. So the important thing about this is kind of like how in smart contracts, you have to trust the blockchain to run, and maybe there's politics or hard fork risks of the blockchain you have to understand and decide that you're okay with. The important thing is that you don't have to trust the application developers. Like who wrote a smart contract doesn't matter. It's even better if it's an anonymous profile photo that wrote the smart contract. You get to look at the smart contract code it yourself and know that it's being run correctly by the blockchain platform. It's the same thing with these imperfect but pragmatic and available today confidential compute products on clouds. You don't have to trust the account owner at the cloud who wrote the code before deciding to trust your sensitive data or link your account to it. You get to look at the code yourself or have auditors around evaluate it. And what you get is that the cloud tells you this is the code that's running. This is the hardware spec that it's running on. So you use that to make your decision to trust it, not having to trust the owner of the account or the developer who originally wrote the code. So now let me go to, there's a lot of really interesting examples about that. The point of this slide is to give some pointers to some interesting applications you can, that are like mechanism design using this kind of tech. But let me just go straight to how this works to use it for the TikTok apps that I just showed you. So this is going to be in about 3 steps. The first step is to take whatever browser or mobile OS you would have used to interact with the platform via an app and actually run that browser inside one of the confidential compute VMs as a TE. This means that you essentially get the same kind of privacy as running it locally, even though it's in a cloud and it can be run remotely. You know the code that's running, and you know that whoever wrote that code can't be looking at the data that you link there. In principle, running a browser in a confidential compute VM on a cloud doesn't look any different to the platform than actually just using it on your browser, on your laptop. In fact, you can have the TLS traffic start in the confidential VM, but routes through the outer layer through the user's own laptop and therefore the user's own IP address. It could even copy the user's fingerprint. It can be an exact replica of the browser that they were going to be running on their laptop. Just now it's running on a cloud VM and going out through their own IP address. So there's no way for the platform to be able to tell that this is happening. Also, if you wanted to do something that's either automation or a browser plugin or having an AI agent, help you carry out the agentic tasks of doing interactions on the web app, the user can bring that themselves. It doesn't alter the trust model of having the browser start off in the confidential compute. Now, the last thing to mention, and I'll give the name OAuth3 for this and explain a little bit about this in a moment, is you can separate the task of collecting this data and handling the account delegation to do this from the specific apps, like the examples that I gave that would use it. So you should think of this as, maybe you're familiar with, or I'll just tell you that there was a project called SolidPod, which was a Web3, not a Web3, what do I mean by this? W3C, right? World Wide Web project from Tim Berners-Lee that says, oh, you should decouple applications from storage. This is like but they had no answer to confidentiality. Like you could pick lots of different storage providers, but each one of them would get to see all of your data. That's very limiting. So here the idea is you can have a data pod where you can store account credentials, delegated accounts, instances of browsers logged into accounts, and data that you've collected from your own account. And you can store that in a confidential VM of your choice. You can choose which cloud to put it in, which TEE provider to have. That's your data pod. You as the user are fully empowered and in control of it. If you want to delegate this data to third-party defined apps, then you can do so. You don't have to go redelegate the account just to be able to use a different form of an app. And you don't have to ask the platform's permission for all of this. All they know is that you have a browser. You've looked at your own watch history through a browser, but what you do to delegate with it can be done then this way without the provider having to know. So we use the name OAuth3 for this. This is a very funny troll of a name. Maybe this pattern, if you're familiar with web standards, this kind of delegation intermediation is a lot like kind of the familiar thing of OAuth. Normally, OAuth is something that has to be provided by the platform, and the abilities that it provides are only those abilities provided, defined by the platform. They tend to be very limited. If you search for OAuth3, you just get a page that says OAuth3 just definitely doesn't exist. So it's sort of like an anti-memetic space. That's a good place to put a new name. And so it's a good joke of a name because it's not really a standard. The whole point is adversarial interop. You don't need the platform's permission to do this. In fact, it doesn't, the platform can't stop it if they tried because it can just blend in with ordinary traffic overall. So, this modular approach of it's your own account data, nothing stops you from making a log of your own account data. And if you choose to delegate it to third-party applications, which you should, that's a good idea. You can do that. This is a modular way of doing so. I think that I am going to stop there. I mentioned what the point of OAuth3 is and the rationale for that. I think a very interesting trend that's related to this is the expansion of AI agents in operating systems in browsers. This leads to a really interesting blurred line or breakdown between what counts as a user-initiated action and what counts as automation. If an agent helps you carry out some task, then that's somewhere in between automation and just carrying out the express intent of the user. The sharing and delegation to apps that I'm advocating and the use of confidential compute is really unrelated to whether you do agentic actions on your browser or OS. So these are separate, but it's really the use of AI agents that is pressing this line about what counts as automation versus defense. So yeah, I will stop there, and I guess I will just lastly. Thought I had some link here I wanted to say. All of the code that I mentioned for this is open source. Like the apps aren't out yet, but we're doing the Ethereum style working in the open. So I'd encourage you to go look at this Teleport Talkscope repo. It gives you tools for handling your own accounts and running them in confidential compute. And that's all. Thank you.